Hey guys, today we're going to talk about transformations to the quadratic functions that we were talking about last week. Um, you're going to be doing this worksheet on your own, but I want to give you a couple of pointers so that way you know where you're going. Basically, y equals x squared is going to be our parent function, and we're going to be doing some transformations to that. So we're going to be moving it left, right, up, down. We're going to be reflecting it. And we're going to be stretching and compressing it. So that's what these notes are all about. In this first page, this should be review. Remember HK is your vertex. So here they gave you an example, +2, +5. There's my vertex. A was positive, so it opened up. And if it opens up, remember your vertex is a minimum. So that's all you're doing here. Now I will warn you, let's say there's no H or K value, it's an assumed 0. So like number 9, right? See how there's nothing with the x squared or nothing with the x squared? So that means your H is 0. So you wouldn't say x minus 0, you would just say x squared. And then your K is -5. So 0, -5 should be your vertex. So just to kind of give you a couple places you might get caught up. But that side should pretty much be review. Then we move into vertical translation. So vertical translation is your up and down. Again, you're starting with the function f of x equals x squared or y equals x squared. So that's going to be where they start you every time. So this chart shouldn't change because -3 squared is 9. -2 squared is 4. 1 squared is 1. 0 squared is 0. So you're always starting at that origin. And you have that symmetry. I don't like this. Okay. So there's that. And then what they want you to do is they want you to change the coordinates. So if you look here, my advice is to start with your vertex. So my vertex is at 0, -4. Oops, I wrote that in the wrong spot. Let's try that again. My vertex is at 0, -4, so I would start there and then pick smart x coordinates. So you want to stay as close to that vertex as possible, but you also want symmetry. So we're going to say we'll go to the left, so -1, -2, -3. And then we'll go to the right, 1, 2, 3. So pick smart coordinates. Plug them in, see what happens. And then same concept here. Plug them in, see what happens. Start with your vertex, pick smart coordinates, go to the left, go to the right, and see what happens. And then you're going to graph them. So notice on here it says on each grid, sketch the y equals x squared graph. So you want that on both of these, right? You want to graph this on both. And if you want, choose a different color so that way it stands out to you and you see what happens. But you're going to put the x squared minus 4 with it on here, so you should have 2 graphs on this. And then the x squared plus 1/2 over here. All right, so that kind of sends you in the right direction. Complete that. This is the same concept, except for now we're doing a horizontal translation, so it's moving left and right. Again, they started you with that function. This part shouldn't change, so you could actually copy and paste that table. Our vertex is 3, 0. And again, we're going to pick smart points. So you want to move 3 to the left, 3 to the right. Okay, so we're at 3. To the left would be 2, 1, and 0. Right? And then we're at 3. To the right would be 4, 5, and 6. So I don't want you always picking 0, 1, 2, 3, -1, 2, 3. Okay, it doesn't always work that way. Find your vertex and pick the points that are immediately to the left and immediately to the right. All right, and then again, once you get down to that bottom, you're going to put the y equals x squared graph on here, and you're going to put the x minus 3 squared graph on here and see what that changes. You should see a horizontal shift. Same concept over here, but with the x plus 2 And again, you should see that horizontal shift. When you get to the next one, this is putting them both together. So you don't have to just move it up or just move it left. You can move it up and right. You can move it down and left. You can move it wherever you want. So this kind of puts two together. Again, smart point picking, right? Smart point picking. We're going to change keep. So we got -3 as my vertex and -2. All right, there's my new vertex. Again, pick 3 points to the left. So to the left would be -4, -5, and -6. So pick smart points because these will be way easier to plug in and you'll get way smaller numbers. And then pick 3 points to the right, so -2, -1, and 0. Right? Pick smart points. Pick smart points. Wherever your vertex is, go immediately to the left and then immediately to the right of it. And that'll kind of keep you with that. It'll keep you with smaller numbers in here. Easier to graph. So complete that one, graph it. Again, 2 graphs on each. So you should have that y = x squared. You should be tired of drawing this by now. Because, sorry. Yeah, you should definitely be tired of drawing this because you're drawing it on every single graph. Because they want you to see what's happening. Here's the original. Here's what the transformation did. Where are we at? Reflection. Reflection. So reflection when a is less than 0. So when you have that negative a value, it's reflected over the x-axis. It's reflected over the x-axis. So you see here y = x squared and y = -x squared. So that negative flipped us over the x-axis. So they, again, just want you to make tables. They already gave you the coordinates. See what happens. Now I will say be careful here because remember your exponent only goes with what's right before it. So if you're plugging in -3, it's -3 squared is +9 times -1 is -9. So be careful with plugging stuff in. And then they kind of did everything here. So notice here we're going to have a reflection. We're going to change our vertex. We're going to have a horizontal shift and a vertical shift. And again, they want you to graph your parent function, y = x squared. And then they want you to graph the new one. And again, pick smart coordinates. Pick smart coordinates. Let's see, our vertex is 2, 3. So I'm going to pick coordinates to the left. So 2, 1, 0, -1. And then I'm going to pick them to the right, 3, 4, and 5. So stay right next to that vertex. All right. And then plug them in, find some stuff, and graph. So you should see 3 transformations there. You should see it moved horizontally, you should see it move vertically, and you should see it reflected. Vertical stretches and compressions. So that's when you see the number, your value of a not being 1. Right? Here, our value for a, y = x squared, our value is 1. You're going to start seeing that change. And it can change lots of different ways. You could be stretching, right? If your a is greater than 1, so see that 2x squared, you're going to be taking your graph and you're going to make it really, really long and skinny because you're doubling, right? You're doubling. You're going to make it really, really long and skinny. When you see a value between 0 and 1, so like 2/3, don't just assume every fraction is between 0 and 1 though. Okay, 3/2 is bigger than 1, it would be a stretch. Okay, but 2/3 is definitely between 0 and 1. You're going to see a compression, so you're going to see that graph get really short and fat. Really short and fat. It's going to get wider. And you can kind of see that here. So the blue represents our x squared. Y = x squared, that's our parent function. So notice when it became 4x squared, so when it was greater, we got that tall and skinny. right? We got that tall and skinny graph. And then when it was 1/4, we got that short, fat, compressed graph, compression. So we had our stretch, which was the 4, and we had our compression, which was the 1/4. And then graph them. Again, you should have 2 graphs on each, so you should have y equals x squared on here and y equals 2x squared. And then the last part, explain the transformations. So it says for each of the following, state the vertex. So we want to state the vertex. Here, there's nothing with my x, so we're going to say it's at 0, and then positive 2. And then the transformations that must be applied. Applied to your y equals x squared function, your parent function. So that plus 2 is going to move your graph up 2 units. Ay, so many bells. And then just go from there. So here, my new vertex, again, there's nothing with that x squared, so we're going to say 0, -3. And I would just kind of start from the beginning. So that negative out front is going to be a reflection over the x-axis. That 1/2 is going to be a compression. So you should see it get short and fat. And we're going to move it down 3. Down 3 units. So again, you're just telling me what's happening, right? What's happening to your graph. The negative out front, remember that's a reflection. The A value tells you if it's a stretch or compression. And then did I move left or right, up or down, right? If it's with your X, that's going to be your left and right. And then on the end is your up and down. So vertical translation or horizontal translation. All right, and so the step pattern. The step pattern, basically, we don't want to do this table every time we want to graph, right? Is there a shortcut? Do I have to sit there and plug all these values in? And the answer is no, there's a pattern. So we're going to look at that pattern. If you think about the y equals x squared function, which I know you've written this a million times. Oops, I didn't mean to do that. There you go. No. I don't know what I'm doing here. We're going to try this again. All right, x and y. All right, so let's do -3, -2, -1, 0, 1, 2, 3. You should be tired of writing this by now. So here we get 9, 4, 1, 0, 1, 4, 9. So notice what happens, right? From here, from 0, 0, your next point is 1, 1. So you went over 1, up 1. Right? And that's what they're telling you here. And then from that point, you're going to go over 1, up 3, right, to get that 2, 4. And then you're going to go over 1, up 5. So it's 1, 3, 5. Over 1, up 1, over 1, up 3, over 1, up 5. And that's your basic step pattern. So how are we going to use this? If your A value changes, then your steps change, right? Because your graph is getting either tall and skinny or it's getting short and fat. Okay, it's either stretching or compressing. So what's going to change is your step pattern. So here, if you're trying to do the 2x squared, you would have 0, 0 still. We have the same vertex. But now I'm going to go over 1, up 2, and over 1, up 1, 2, 3, 4, 5, 6. And that's both ways. Over 1, up 2. Over 1, up 6. And notice my graph got really tall and skinny. So that's all